Alright, boys and girls, welcome to our second video lesson in Chapter 9, our continuing quest to find out the secrets of conic sections. Today we're doing everyday ellipses. Alright, here we go. Okay, an ellipse is like a stretched out circle. It's oval. Okay? An ellipse is a locus of points, a set of points, such that the sum of the distances to 2 points, we call these points the foci, is always constant. In other words, if I take any point on the ellipse, if these two smiley faces are my foci, of course this point right here would be my center. Okay? But if I take any point on the ellipse, say for example I choose this point right here, that means now that this distance plus this distance is equal to some number, alright, which means now if I take another point, this point right here, this distance plus this distance is equal to that same number. If I take another point right here, this distance plus this distance is also equal to that number. If I choose another point, we'll try to get a different color, but I can't. So if I choose this point right here, this distance plus this distance is now also equal to that same number. So all those distances add up to the same number, the same constant. A couple more words you need to know. Okay, the major axis of an ellipse goes from edge to edge of my ellipse the long way through the center. It's like the big diameter. So our major axis is this length right here from edge to edge through our center point right here. Okay, that's going to have a length of 2a. My minor axis is perpendicular to the major axis. It's the shorter diameter type length, so it runs through the center point from edge to edge the short way. Okay, it has a length now of 2b, and the distance from focus to focus is going to be 2c. So the distance from the center to the edge the long way, that has a distance of a. The distance from the center to the edge the short way has a distance of b, and the distance from the center to the focus has a distance of c. And what's interesting here now is those three values are Pythagorically related, such that b squared plus c squared is equal to a squared, because a is the longest piece. Okay, we will derive the equation of an ellipse in class, but it's right here, such that x minus h squared over a squared plus y minus k squared over b squared is equal to 1, such that hk is my center point, and a, of course, is my major axis length. It's half of my major axis. B, of course, is half of my minor axis, and c is the distance to my focus. Okay, I can also have a vertical ellipse. Oh, I need to turn my marker on. So there's a vertical ellipse. If my center point is right here, this distance in red, of course, is now a. That's half of my major axis. This distance in green, of course, is b. That's half of my minor axis. And this distance right here to my foci, if these are my foci here and here, that distance is c. And of course now still b squared plus c squared is equal to a squared. Okay, the equation is going to be the exact same thing, but this time the larger number, a, is going to be under the y. So I'm going to have x minus h squared over b squared plus y minus k squared over a squared is equal to 1. So we can tell right away if an ellipse is horizontal or vertical by looking at the larger number in the bottom of our fractions. If the larger number is under the y, it's vertical. If the larger number is under the x, then it is horizontal. Let's try one. Oops, one more thing we need to know. The eccentricity of an ellipse, it measures the roundness or the flatness. It measures how ovular our ellipse is. The formula for eccentricity is c over a, so it's this length from center to focus over the a length, which is center to edge on the major axis. Okay, if that value is 0, then our ellipse is a perfect circle. So if the eccentricity is 0, then it's a circle. And if our eccentricity is 1, then our ellipse actually is no longer an ellipse. It is a segment. It's almost like it's so stretched out that it becomes flat. It is a segment. Alright, let's try some. Let's name the stuff. Well, looking right here, we have a vert ellipse. When we do our equation, we make sure we put our a under our y. So my center point is going to be right here. That's at 0, 0. I can't tell right now of where my foci are, but they're going to be somewhere on my major axis in this range. You know, here and here, somewhere around there are going to be my foci. My major axis has a length of, let's look. This has a length of 8 right here. This is a length of 8 right here. So my major axis is actually 16, but more importantly, a is equal to 8. Okay? My minor axis, this has a length of 6 right here. This has a length of 6 right here. So my minor axis has a length of 12, but more importantly, my b is equal to 6. So now let's figure out what my c is. We can figure out what my c is in order to find the foci by doing a squared is equal to b squared plus c squared. Okay, so a is 8, so 8 squared is 64, is equal to b squared, which is 6, so that's 36 plus c squared. And I subtract the 36 from both sides. It looks like c squared is equal to 64 minus 36 is 28, which means c is equal to root 28, which is 2 root 7. Okay, so my foci are going to have a length of 2 root 7, which is approximately, don't tell me, a little more than 5. So my foci are going to be somewhere in this range, like here and here. But to write those mathematically, my foci are going to be at, and there's 2 of them now, 0, comma, positive 2 root 7. And 0, comma, negative 2 root 7. Okay, so my equation now, it's a vert one, so it's equal to x minus 0 squared, or just x squared, because h is 0, over my b squared, which is 36, plus y minus 0, because 8k is 0, so y minus 0 squared, or just y squared, over my a squared, which a was 8, so that's 64, is equal to 1. And there is my equation. Let's look at this guy right here. Let's name all the stuff for this ellipse. I have foci at 6, comma 2. So that's right 6 and up 2. That's going to be right here at 6, comma 2. There's my first focus. My other focus is at neg 4, comma 2. So it's right here. Doing my best here with my Marshmallow. Okay. Now my center is going to be halfway in between those 2 points. So my center is going to be 5 units over, because those had a total distance of 10. So my center is right here at 1, comma 2. I'm doing my best here. Thank you. 1, comma 2. So there's my center. So I already know now that h is equal to 1, k is equal to 2. I also now know that my distance from my center to my focus is 5. So C is equal to 5. I'll just make mental note of that up there. Now my major axis has a total length of 18. So from edge to edge through my center, it's 18. So I'm going to have 9 on each side. So I have 9 units this way, 9 units this way. So my edges are going to be right here of my ellipse. And more importantly, if my major axis is 18, that now means that A is equal to 9. I can now use my Pythagorean theorem to figure out my B, because I do know that A squared is equal to B squared plus C squared. Well, A was 9, so that's 81. 9 squared is equal to B squared plus C squared. C was 5, so that's 25. Subtract the 25 from both sides. 81 minus 25, I believe, is 56. So 56 is equal to B squared, which means now B is equal to root 56, which I think we can take out of 4. So that's 2 root B is equal to, I'll write this up here where I have room, 2 root 14, which is approximately 7 point something. So I know that B is about 7 point something, but our minor axis is 2B, so it's going to be 4 root 14. Okay, so I'm going to go up 2 root 14, which is about 7, up this way-ish. Same thing down here. So if I draw my ellipse, it's going to look like this guy here in red. I'll do my best. There it is. Not too bad, not too good either, but you know how it is. Now let's just write our equation. We have a Zant ellipse, so I know it's going to be x minus h squared plus y minus k squared over a squared over b squared is equal to 1. Well, h in this case was 1, k was 2, a was 9, and b, of course, was 2 root 14, which you remember was root 56. So I'm going to have, when I'm all done here, I'll do it in green so we can see it, x minus 1 squared over 9 squared, which is 81, plus y minus 2 squared over root 56 squared, which of course is 56, and that's equal to 1. So there is my equation. All right, folks, that's it. Have a great day. We'll see you soon.